is that we, as SF Hacks, are San Francisco's largest collegiate hackathon. As you can see on our right is our team for this year. And we will actually be holding our annual hackathon March of 2022. If you want to learn more information about our upcoming hackathon, you can follow our Instagram, go on our Discord, and we will be posting our links later on throughout this workshop. And in preparation for our hackathon, we will be hosting these series to help prepare our attendees so that they can utilize these tools for our hackathon. And so for our first workshop, we will be having, our introduction to mobile application development presented by Chris Cree. So I will now stop sharing. And if Chris, you want to share your screen, feel free to. Oh, Chris, I think you're muted.
Can everyone see the screen now? Yeah, okay. Okay, so the agenda today, we're going to talk about Android Studio, which is the IDE that you would use to develop Android apps. And even though this is mobile development, the reason we're talking about Android is because it's the most open and accessible of the platforms. You can basically build Android apps if you're on a Windows or Mac, you know, a Linux box. Whereas if you wanted to build iOS apps, you have to have a Mac, and so you're more limited to what you can actually run and deploy to. So that's why we're going to talk about that. We're going to talk about virtual devices and emulators. We'll also talk about the key artifacts of an app, the layouts and views, activities lifecycle, and explain what an activity is, logging that can be helpful.
Get used to using GitHub. So basically what
there was some audio going on there. Please mute if you're not presenting. So logging can be useful if you're debugging. Talk about processes and threads, network utilization and retrofit. And retrofit is just a networking framework. And then we'll talk about persistence. And we got lots of exercises in this workshop. So we'll try to do some of them live, and depending on how much time they're taking, we might skip all of them and let you work through those, but we'll try to do some of it live as well. Okay. So we gave the link to download Android Studio. It's free to install. It might take a little bit of a while to install, but to create an app, from the beginning, it's pretty straightforward. There's a little wizard that helps you. You get to the welcome screen, and you see something like this. Select the project template. And if you select an empty activity, which is this one over here in the upper right, and you click next, the next screen you'll be shown is you can give a name for your project. You'll give it a package name. That's important. Usually you will use a reverse domain name, which is a good standard to use. That will be your ID of your app. So when you install the app onto a device, a virtual device or a physical device, that will be its unique ID. Okay, that's the ID of your app. It becomes even more important if you ever try to upload this into the Google Play Store for distribution. You have a location for save location for your project, and then have a language. Kotlin is the language that's most often used. I put Java here because thinking that this was for a hackathon that most people don't want to learn a new language just for a hackathon. So picking Java might be a more expedient way to get an app built. But if you're going to do this for a project beyond a hackathon, I advise looking up Kotlin. It's a pretty cool language, and it runs on the JVM as well. You also see a minimum SDK below the language. That means basically what's the oldest version that you want to support in your app. So, for example, if you have you're working with a partner and they have you might have Android 11 on your phone, but if they have Android 7 or something like that, you want to make sure that whoever's going to use your app, that you're going to support back to that level. So picking the min SDK is important. And in fact, it'll show you of approximately all the devices that exist in the world that are still running. What percentage are you going to address if you go back that far? If you want something only support modern devices, you're going to get a smaller percentage. Okay. Okay, great. Let's go on to the next. So when you open up Android Studio, it kind of looks like this. So Android Studio is the official IDE for building Android. You don't have to use it, but most people do. It's based on an IntelliJ. So if you've ever used IntelliJ before, it'll seem very familiar to you. It supports both Java and Kotlin, as I've been saying. Kotlin is preferred for new applications. However, there's more than 10 years of Java apps out in the world. So in the future, if you're ever going to get a job doing mobile development, you're going to be probably running into a lot of legacy Java code. So expect that. The good thing is they're interoperable. So that's not a problem. So if you look at item 1, there's our toolbar up there, which you have in most IDs, save files, go back. There's some cool buttons up here. The green, that looks like play button, that basically means run the app. There's also debuggers up here, those things that look like little bugs. So you can also attach a debugger after you've already started the app. The number 2 is your navigation bar that kind of tells you, what depth within your project you've navigated. So the top level is your application, then app, source, main, Java, com, and continuing on down to your, as you go deeper into your package for your Java code. Your editor window is the bigger window in the upper right. That's where you'll see your Java code or Kotlin code, whatever it may be. Your toolbar window is number 4. That's just other tools, how you can jump to different views right there on the left side. Tools window is 5. So basically, this one is currently showing the debugger. You could also show a console or logcat. So depending on what you're doing in the development process, you have a different view open in that lower pane. And number 6 is a status bar. You'll see something like, whatever it might be, compiling, syncing, and things like that. So, it's an IDE. It's, like I said, it's based on IntelliJ. So if you've ever used IntelliJ, it's going to seem pretty similar.
Sorry to interrupt. We do have a question in the chat, and
okay.
they ask if we have to download Unity.
Unity? What was the question? Download what? Could you repeat the question? I'm not hearing you. You're muted.
Oh, someone asked do we have to download a Unity? That's what they ask.
A Unity?
Yeah.
Unity is something for if you want to build like 3-dimensional graphical art. You don't have to download that. In fact, Unity is for, like, let's say if you wanted to, let's just say that's not mainline application development. If you wanted to build something that had 3-dimensional objects and rendered, you could download Unity. Unity sort of runs, builds a library that runs with Android or iOS. You're actually coding in C# if you're doing Unity development. So that's a very specialized part of Android development. Okay. Oops, let me go back. So in little navigation tips in the IDE, there's these project buttons from left to right here. The one that looks kind of like a target that basically will say select the open file. So if you have a file open in your editor window, if you click that button, it will take you in the project area and basically locate the file that you currently have open. So it's very handy. The one just to the right of that is a collapse all, as it kind of looks like. The gear is a show option menu. And then if you don't want to see the project panel over on the left side, you click the looks like the minus, and that will hide that panel if you want more space for the editor. Some handy keyboard shortcuts. I find Control F to find something, Control R to replace. If you want to find the declaration of something, sometimes you'll see a variable or a class that's referenced in your current view, and you might want to say, well, where is this thing declared or defined? By using Control B, that's a very handy, basically a shortcut that will just take you to the file class where that thing is defined. That's super helpful. Also, if you want to just find some text in the path, you can include Control Shift F, and basically you could pull out and do a broad global search. Also note that anything I said in here that references control on a Mac will be command instead of control. Okay. So one thing that's very handy when you're developing for Android is creating a virtual device. So in Android, in the IDE, there's if you under the tools menu, there's the AVD manager, which stands for Android Virtual Device. And when you pull it up, you'll see this view that you see here, and these are device profiles. These are predefined device profiles that you can select. You can modify them. You can modify memory for them or disk space for them, but you basically select these profiles, modify them a bit, and then that's basically a configuration for a virtual device that you can run and test your app on. So even if you don't have an Android phone, you can test your app virtually. And when you do that, the emulator, as you see here in this screen, the emulator will populate with your configuration and show you the virtual device. That's what you're seeing there. It supports a lot of things in Android that an Android device would. Believe it or not, you can basically simulate phone calls and SMS. There's some command line tools that come with the Android SDK to help you do that. You can also simulate like what happens when I rotate the phone. You can see some of these buttons on over to the right. You can see the little arrows. So like, what happens if I rotate the phone? Does this affect the app or not? You could also simulate taking a photo. There are some limitations to the emulator. You can't really simulate Bluetooth connections. You can't really simulate NFC, near field communications. In location, you can kind of fake. And if you click that three dots overflow menu that you see, you'll see what will happen is you'll pop up this view that I'm showing you in the lower right. You can actually enter a geolocation that you want to define for your device as if your device was, connected to GPS. So it sort of fakes your GPS signal. And you can even, you see in that lower, there says GPS data playback. If you wanted to create a sequence of GPS locations, you could basically define a sequence. So you can, basically kind of simulate having the user walk down a certain path or something like that. Okay. And you can see there's a playback button there as well. Okay, so we saw how you make a little app from nothing using the wizard. Well, if you want to run that app, you just click that green play button and it loads. Basically, first it builds your app, then it will install to the emulator automatically. You don't have to do anything, and it will start up. So it does really three things: build, install, and start. Okay. So if you also you're thinking, well, how do I input to it? Because obviously I can't touch or type on it. So once you click on the emulator, using your regular mouse will basically simulate a touch to the device. And if you need to type, you can type on your computer keyboard, and it will take that input as if you had been typing on the Android device keyboard. Okay. All right. Oh yeah, by the way, even though this is the emulator, if you wanted to connect a physical device to it, you can basically take a USB cable and connect a physical device to your computer and install that way. And once you do that, when you click that run button, it will become one of the options for where you install. One thing said, you will have to turn on developer options on your phone to do that. And there's kind of a secret to turning on developer options. You go into the phone settings, you go down and find the build of your Android operating system. You click on it 7 times, and you get a pop-up that says you are now a developer. Okay, so that's the secret of enabling developer options on Android phones. Okay. Okay. Again, continue with Android Studio. If you look in the project window, you'll see this XML file at the top called Android Manifest. And that Android Manifest has all sort of the metadata about your app. We'll talk more about what that is. Below that, you'll see Java, and you'll see packages, and then you'll see files in the package. So in this case, very simple. We have our Hello World package, and we have main activity. That's our only class we have at the beginning. You'll see some colored items. As you see here, it looks like yellow. In some IDs, it looks green. Those are tests classes. So those are classes that will not be built into your app when you distribute or install it. Those are basically classes where you can write your unit tests and instrumented tests, but they do not become part of your deployed app. And then below that, there's a folder called Res, resources. And in there, you'll have various resources that are not regular code. They are a combination of layouts, which are other XML files. We'll show you what layouts look like in a few minutes. They could be files just full of strings that you use in your app. And it's generally a good practice to put your strings in a resource file and not embedded in your code. The reasons have to be like, it's basically a good practice. Plus, if you ever try to localize your app for another language or region, it's much easier to basically take one XML file and translate that for a different language or region versus trying to make different versions of all your Java or Kotlin files. Also, in the resources, you'll have images. Here we have some PNG images, but it supports other types as well, including vector graphics. And finally, at the bottom, you have these files called .gradle. So Android uses the Gradle build system. Gradle runs, it's a domain specific language. It's based on Groovy, and it runs on a JVM. So anyway, those will be your build files. Gradle also uses the Maven dependency system. So you can specify libraries located somewhere on the network, and they will go to a repository, find that library, and install it for you. So, okay. So it looks like some key artifacts of an Android app. First, I mentioned the Android manifest. So their manifest describes your app. It's all that metadata. It's in XML. That's the uppermost rectangle you see there. And in your manifest, you have like a package name. As I said, that would be your unique identifier for your app. And then you have some other things like what's the icon that this shows on the screen. And there's a lot of other information I'll talk about in a few minutes. And then you need at least one source file. So in this case, we just got a Hello World app right now. We have a main activity. And this is a basic UI component. An activity is something that shows on your screen. It's the basic UI building block. These can be written in Java or Kotlin, and you'll have a lot of methods that are overriding methods from the superclass. You can see the main activity extends app compat activity. App compat activity comes with the Android SDK, and this activity basically subclasses from that, and we're overriding the onCreate method here. We'll have a little more about that in a few minutes. And as I said, in the previous slide, there's these resources, which are layouts, images, and strings. So one resource that you need to have is a layout. And a layout is an XML file that describes how that activity is going to look when it displays on the screen. In this case, the topmost element is a constraint layout. We'll show you what that looks like in a few minutes, but it's basically just saying that things that we're going to see, views, widgets on the screen are going to have constraints on them that basically tell us where they should be laid out. And then we'll have types of views in here. And for example, a piece of text that you would want on the screen would be a text view. Okay. Okay, let's look a little bit closer at that manifest. Like we said, it's the metadata of your app. And we said it has a package in here. You have an app version code. You have your icon that you want. So in your resources, you would have an icon and you'd reference it here. And you'd have a name that you would want displayed below the icon when you install your app. Then you'd have every activity that would be in your app has to be referenced in your manifest. If you don't, you'll get a warning and your app won't build. So here we say main activity is one of our activities. You could also give it a label, that doesn't matter. Also, we can give it an intent filter. This intent filter here is very important. We won't go too much into the intents, but intents are basically asynchronous, loosely coupled messages. So Android apps don't have a main method. Even though we're talking about Java, they don't have a main method. So their entry point is an activity that has the action main, and the category is launcher. So the main screen on a phone, when you're looking at the home screen and you don't have any apps open, what you're really looking at is the launcher. The launcher is displaying all the icons for your different apps. So when you click on the icon for an app, that causes an intent to go around your phone system. And that intent is main. So your app, basically this manifest is saying, I have an activity that is able to handle the intent, the action of main launcher. This specifies, this filter here specifies, this is the entry point of my app. I might have other activities in my app, but this activity is the entry point. This is the first thing that the user is going to see. Okay. Again, this was built by default when I just went through that wizard and created a new app. Okay. All right. The other artifact I talked about was the Android activity. Again, it's subclasses from an SDK class. The one thing, like we said, you don't have a main method. So how do you run code? Well, we said there's an intent that opens up an activity, but how does the code of our activity get run? Well, what Android does and iOS does this as well. You as an app developer are you're implementing a bunch of callbacks or listeners. right? So here's the case that basically when our activity is created, we will get a call to on create. And that is our option to do something at the moment that the activity is created. So one thing you always have to do in these callback methods, you have to call the super of whatever the form of that method is. So we call super on create. But the next line is very critical. It's called set content view. And you can see I'm giving an argument of our layout activity main. So that is a resource XML file that specifies what the activity should look like. I have to do that. So that's very critical. Okay, that sets the content of my screen. Now, if I want to be able to handle input from the screen, like clicks and text input, I have to do more here, but this is the very bare bones basic that I need to do to show a screen and to start an app, okay? And I said in the previous screen, I was referencing a layout, which is an XML file. This is what a layout looks like. This top one is basically when we ran through that new app wizard, this is what gets generated. There is an outermost element, which is usually some sort of layout. And in this case, it's a constraint layout. We'll skip over a few of the details here. And then within that constraint layout, there's a text view. So I want to show a piece of text, and its attribute for text is hello world, which we saw. And then because we're in a constraint layout, there's a bunch of elements here to say how this thing is constrained. We'll take a look at that in a second too. But you're basically saying, where does this view go within the overall screen? And so we're just saying, it's basically has constraints relative to its parent. And that's enough details on that for now. But in general, these layouts could get much more complex, and they could have a hierarchy. So if you look at this graphic at the bottom, there's a view group, which is a layout, like a constraint layout at the top. That's the top of our hierarchy. Within that view group, there can be views, as you see here. And there can be also sub view groups, which also have views. Okay, so these can get a little bit complex. You want to have not too many layers of view groups, because it can start to have a performance issue as far as rendering. And we'll talk more about rendering in a few minutes. Okay, again, constraint layout. When you open in this XML file, if you open up this XML file in the designer view, you'll see this graphical sort of UI down here, where you can see these squiggly lines. Those are showing you that text view in the middle of my screen is constrained by the parent. It's constrained to the top, it's constrained to the bottom, it's constrained to the right and left. If all the constraints are equal, that view will be right in the middle. So think of all those four things as being sort of attachments. And if they all have the same weight, basically your text view will be right in the middle of the screen. So if you look on the right, you'll see 4 places where it says 0. If you would put some values in those, you would start to see that view would drift to one side or the other. Okay. Also, that slider that says 50, if you slide that, you could also specify that you want that to have a certain weight towards one side or the other. Okay. But constraint view without any of those values set is just going to basically give each of its constraints an equal amount of weight. Okay. So we talked about text view so far, but there's lots of other kinds of views. So for example, not only there's text view, there's image views, there's buttons. That's no surprise. You can see here in our view group, our view hierarchy, we have a done button. So you can think about if our top level view group, it might have a label or a text view that says profile pic. It's just a kind of label. And then it might have an image view that's actually an image. And then below that, you might have another view group that has a label called name. It has an edit text, basically a text that you can actually edit, and you can enter a name there, and you might be done. Scroll views can be handy when you have a very long layout. Now, we describe this as all being XML, but really we don't run XML in an Android app. What happens is your XML gets inflated to an actual, basically an object graph. And that object graph is what is kind of, I'm trying to represent in this graphic here. A view group, a subgroup, and that. So when you ever hear anything talking about inflating a layout, they're saying the conversion of that XML layout to an actual object graph in memory. Okay. So it sounds kind of static. You're saying, well, all this, we have to define all this XML, but there's also dynamic ways to add views and remove views. You can do it in code. It's a little bit harder to manage that way. So that's why we kind of do the designing with the graphical designer and let that construct our XML. But the other thing I should mention, that the containers or the view groups or layouts, as you might call them, those are invisible. So you don't really see those at runtime, okay? They're just the container that helps us organize all those views. Okay. Now, that all said, Android, like any mobile platform, iOS included, are constantly under development and new features are coming out. So if you're starting to build an app for the hackathon, you might run across something called Jetpack Compose. It's a completely different way to build your UIs. So it's using actually declarative Kotlin code to build your UIs. And it's interoperable with the view system that I just explained. For a hackathon, I would advise against this because you have to learn Kotlin to be able to do it. And two, it's brand new. Version 1.0 was just released last summer. So because of its newness, there's some instability in the UI, in the tooling in the IDE. And if you get stuck on something and you are looking for an example online on Stack Overflow, you're going to find a lot less examples because it's just too new. And while it was being underdeveloped, it was changing. So you might find a Stack Overflow article from 9 months ago, which may be incorrect. Okay, so just be aware of that. So Jetpack Compose, it's kind of the future of building UIs, but for a hackathon, I would advise against it. Okay, so talked about a layout editor. Let me see, how's our time? Our time is 5:39. Let me see if I can pull this off. I'll show you guys this quickly, how to do one of these. You guys tell me when I switch my screen. So I'll have to stop share for a second and then go out of presenter mode. And so reshare, and you guys tell me if you can see this well enough. How is that?
We can see it.
Okay. All right, so I'm going to try to do the little exercise here that you're seeing on your screen in the presentation. So we see our hello world here, and it's in design mode. And we can select split mode, where you see design mode on the right, and you can see code mode, which you're only seeing XML. Let's go back to design mode. All right, so what I'm going to do now is I'm going to take a button and show you how we add something. So I can take this button and drag and drop it here. Now we're in a constraint layout, And the reason I can see that, I can see constraint widget up here. Also, if I go to the code view, I see that we have a constraint layout as our outermost element. So I'm going to go back to design. And what I'm going to do, so I'm going to connect the handles of this button. And basically, I'm going to, you see what I did there. I basically add a constraint to the bottom of the screen. I can add another constraint. I want to, basically, I'm saying the position of this thing vertically is relative to both the hello world, where that thing is placed, as well as the bottom of the screen. And I also might want to define its constraints horizontally, so I can basically click that, and I'm going to click on to the right. Now, I don't know if you guys noticed that while I was doing that, the XML was being updated. Okay. If I go back, oh, and then let me go back to design view, and we can say our button. Let's say I want my button to, I want to change its text. I can change the text here. I say click me, and or click here, whatever, doesn't matter. And you know what? I'm going to change the button. I'm going to change its ID to up here to demo button. Okay, cool. Now, when I do all that, it says, hey, you're changing the name of this resource. So there could be things that are already referring to that ID. So it's basically Android Studio is trying to keep me from breaking existing code. So if I say refactor, or I could say preview, it's going to show me the code that basically is referencing that. And I could just say do refactor, and now everything's going to be okay. All right. Okay, let me stop that share. Okay. All right. Now, this also, let me show you a source editor exercise that I have in here. Okay, so one thing I'm going to do in here's my main activity, which just basically sets the content view. I'm going to add some code. I want to get a reference to the text that I have there. So I'm going to say, I want a text view. I'm going to call it text view. And you see the ID is helping me. I'm going to find view ID. I'm going to say R ID. And the name of my text is just text. Actually, it's demo text. It's even better. All right. It understood what I was asking for. So we're all good. And if I want to get so basically I have a handle to my text. So if I want to get a handle to my button, I say find view by ID, R ID demo button. I can say, you know what? I want something to happen when I click on that button. I want to be able to react to that. So I can say set on click listener. And then I'm going to say what? I'm going to create a new view on click listener. And basically, I'm going to override public void. Actually, I'm going to on click and passes in the view. All right, there we go. So what is this doing? Basically, I'm saying, hey, attach to this button a listener that's going to react to when someone clicks on it. So let's say text view, and we already got a handle to our text view earlier. We'll say set the text in our text view 2. Yeah. Okay, cool. So, so basically when I run this, what happens is it's going to be hard to show you guys, but let me try. Okay. I'm going to stop sharing. We'll try to share my emulator now. Can you see an emulator, or is not just part of the emulator? No. Let me see if it's going to show. I'm going to try to share. I don't think this is going to work. Yeah, I don't think I can share the emulator. Sorry about that. All right. I'm going to go back. To the presentation. Let me do that. Let's see. All right. Are you guys seeing the presentation again?
No, I don't see it.
Okay.
No.
All right. 1 second. Too many windows open. Sorry. All right. You guys see my emulator now?
No.
Oh man. No, it's not playing nice with the emulator. Sorry about that.
No worries.
All right. So, okay, you seeing the presentation again?
Yes.
Okay, cool. All right, so we showed you how to basically edit some things in the emulator, show you how to basically write some Java code to connect to those things in the emulator, and basically be able to react to things going on in the IDE, in the emulator. I'll let you guys do this, 'cause looking at time, I'll let you guys do the other exercises for yourself. But basically, you know, we can set up, as you see here, we set up an integer interactivity. And part of our, if you're looking out in number 2, we see in the on click, we can increment our counter and we can show that counter in our text. So you could actually see that every time that you would click on that, you're updating the counter, and that number is being updated in your text view on your screen. So one of the things important about activities is understanding that they have a life cycle. We've already seen that there's on create, so that's when your activity is created. So you see at the top here, there's this on create method that tells us that's where we are in the life cycle. The other thing is called on start. So it's another opportunity to run some code to basically say this thing is going to start very soon. It's going to display very, very soon. On resume, this means that your app is in the foreground. your activity could be on the screen when it's in on start, but when it's on resume, that means your activity is in the foreground and it can accept interaction from the screen, like clicking or typing. So if a dialogue, for example, from another app or something comes in front of my app, even though my activity might be partially visible, if I can't interact with it, it basically goes into this on pause mode. And then when my app is completely not visible anymore, that's when it goes to on stop. Now we could go back to on restart, and that's basically like if another app was in front of my app, and now my activity of my app is completely visible again. We go through the on start, on resume, and basically we could loop through the cycle many times. However, when my activity is starting to get shut down, I could go to this on destroy. There's some special edge cases about the process being killed, but I wouldn't worry about that for right now. Those are some special cases that don't usually happen if your device has enough memory. Logging can be super helpful in Android. So Android is a multi-threaded environment, which we'll talk about in a minute. So having some logging can be helpful. You can see at the bottom, that's the logging that's going on there. If someone might want to mute, there's some ringing going on there. If you could please mute, I'd appreciate it. The ring is getting really loud in my earphones. The log messages have levels. So as you can see here, we have a verbose messaging that's basically means give me all the levels. You could also filter on debug or error messages. And you could also filter them with a piece of text here or a regular expression as well. But these log messages can be very handy. You can see here, if you look in the middle of the screen, there's my inactivity on resume. So that looks like the on resume method is actually logging that it went through that part of the life cycle. Also, you can see it went through on create. So very handy to tell you what's going on with your apps. You can here's a little example that, excuse me, can someone please mute their ringing device? I really appreciate it.
I think everyone's muted.
Yeah, I don't know where that's coming from. It's weird. Okay, let me, okay, I'll try to move on. So you can see here in this main activity, I put a log message in on create, on resume, and on pause. And in the log cat here, we can see those messages here. So that can be really handy as you move your app from the foreground to the background to understand what the life cycle transitions are happening. So very kind of important to know as you get further into Android development, to understand that life cycle. Okay, as I said, Android environments are multi-threaded. There's no getting around that. So there is, the most important is when your app is created, there is a single thread that's created, which is called the main thread. And that's very important because that's the app, that's the thread that distributes events to the app. For example, when you click on the, touch on the screen or you type something, that main thread is handling that interaction and delivering it to the app. Also, you need to use that thread when you're updating something. So like all the code that we were looking at in on create, all of that is running on the main UI thread. However, don't run anything that's long running on the UI thread. You don't want to block it. You want to run things on the UI thread and be done with them. The reason is the system uses that thread to refresh the screen. So even the slowest of Android devices are refreshing the screen at 60 frames per second, some of them twice that speed now. So that means you have approximately 16 milliseconds to free up, to do whatever work you want and get off the main thread. So What mostly you want to be doing is any long running work, you want to do it on a background thread or a non-UI thread. If you block the UI thread, you can get error messages like application not responding, also called an ANR. So this is a very common thread scenario on Android, or basically iOS as well. You get events from the user on the UI thread that you want to respond to that UI event. So you might do a request, you might run a query either to your local, persistence on the device, or maybe you're making a network API call. You go get some data, and then you have a result. But so that the result can get back onto the screen, you must basically transfer that result back to the main thread so it can be displayed in the UI. There's various ways to do this. Async task is a very simple way to do this. It might be good for a hackathon. I wouldn't do it in a production app, though. There's some major problems with async task in regards to being responsive to the application lifecycle, or activity lifecycle rather. Handlers are another way to manage threads, so you can look into that. ArcsJava is a widely used reactive stream library that basically supports observable streams. And then also coroutines is a native Kotlin the framework that uses suspend functions. So if you're using Kotlin, you can use that. Otherwise, I would refer to one of the previous 3 options for dealing with threads. Network utilization. So your apps can use Wi-Fi, they can use cellular. There's no coding difference for using a different connection type, so you don't have to worry about that as an app developer. You do need to specify that you're going to use the network in the manifest. If you don't, your app will crash when it tries to use the network. These network requests can't be done on the main thread. So you have to put this on the background thread. There are some frameworks that help you doing this. There's one called Retrofit. It's an open source library. It's type safe, HTTP client. It basically handles all the threading for you. So we'll see some example code of that. If you do Kotlin in the future, there's also a framework called Ktor. Like I said, it's a good library, has lots of good features, but it's only for Kotlin. Okay, so here's a little retrofit exercise. So we put our permissions in the manifest. We put in a dependency because retrofit is a third-party library, so we have to basically download from a Maven repository that library. And then let's imagine we have a user class, the only thing we have in our user is a name. Let's make something really, really simple. Android Studio does know how to generate code. So if you have something simple like that, you could highlight it and say code generate, and basically the constructor, the get name, the set name, these functions can be generated for you. So that's really handy, especially if you're using retrofit. So in retrofit, you define an interface that kind of says like what you want to use, how you want to use your network API. In this one, we have basically one method called get all users. Its type is a call of type list of user. Then we need to create a retrofit client. This bunch of boilerplate code that we need to create, but you also have a base URL you want to set up wherever your network API is hosted. You'll have to set that up, but that's mostly boilerplate code. And then we also specify the JSON library to help us convert Java, well, basically convert JSON to Java and vice versa. So that's a handy factory we need to specify in our client instance. Okay, so how do we use this? So we might have a method called get users. We get a handle to the users API from our retrofit instance there. And then we basically can make a call to get all users. We get a handle back to that call, and we say call in queue. So when we say call in queue, basically we're telling the retrofit library to put some work on its queue of that background thread. All right. And we say a new callback, and the type of this new callback is list user. And this is going to have some callback methods called on response or on failure. So you can put logging code when you're basically you didn't have network or the call failed, but then you can have on response for when that succeeded, and you can get the body of the response. And because the callback was of type list to user, we basically can assign that the body of that response to a list of user. Okay, so how do we use that? For example, you could base in the on resume method of our activity, you could say get users, and that would be use all this code that we've written. Okay, again, actually, we've written very little code, and retrofit libraries generated a lot of code for us. So I'm not going to go through this exercise, but this is another way to show you how to make use of all that code we showed before. I'll let you guys take a look at that. So a couple more things I would want to wrap up this evening before we stop is if you might need persistence in your app. So the options that you have are shared preferences, which are a way to store key value pairs. You also can use just regular Java file IO, not much different than any Java file IO you've used in outside of mobile development. You can use SQLite. That's a lightweight relational database that actually is available on both Android and iOS. And then Android has another framework called Room, and it's an abstraction layer on top of SQLite that makes it a little bit easier to, it's an ORM, so object relational management system. So that's a really handy thing to use if you need like a database type persistence on your app. This example shows you shared preferences. From our preference manager, I can get an instance of shared preferences. And let's say if on resume, I want to get what's already stored, I just say get ent, and the name of the thing, the name, we said this is key value pair. The key is count preference, and its default value is 0, and that's the click count. So we could add this to our previous example, which was counting clicks. And then when the app goes to the on pause state, if I want to save that count of clicks, I could say, oops, sorry. I could say just shared preferences, edit, put the int and key value. The key is count pref. I put the click count and say apply that change. So that under the covers, it's basically storing it in an XML file, but all you need to know is a key value pair. So that's the simplest type of persistence that you could use. And it might be handy during a hackathon. If you need something more complex or relational, I would look at Room, as we showed on the previous slide. Okay, so disclaimer. It's the examples given here were like for first-time mobile developers. This is code that is okay for a hackathon, but it's not really good for like go-to-market production apps. There's a lot of advanced architecture that we didn't cover. Best practices are for mobile development are much deeper topics, but just to tell you what these things are and let you know in case you want to research them yourself. There's intents, which I mentioned earlier. That's an intent is how your app actually gets started, but they can be used for other things. So these are loosely coupled asynchronous messages that can be sent around the whole system of the device, or they can be specified to run only within the context of an app. Also, from an architectural standpoint, a very popular and well-supported architecture is called MVVM, or Model View Model, and that's supported by Jetpack libraries from Android. Also, there's a repository pattern, which is a good practice to use. Basically, what it does is it's an abstraction of your persistence. So you as an app developer, if you set up this architecture, you don't care if that persistence is happening locally on the machine or it's happening on the network or combination there. So that's a good pattern. Also, coroutines we didn't talk about because that's a Kotlin thing. Also, there's Kotlin Flow, also a Kotlin thing. These are, best practices in modern Android development. There's also a thing called Work Manager that helps you manage scheduled work. So for example, if you wanted your app to do something at a certain time of day or at a certain interval, you could basically set up work and create jobs that sort of run in the background. And another thing we didn't talk about, again, because it's Kotlin, Kotlin multi-platform for mobile is a pretty exciting technology that allows you to use one language, which is Kotlin, and deploy code to both Android and iOS at the same time. So that has some very promising things for the future. But again, it's pretty new. Some resources you can check out as well if you think you're going to do mobile work and you want to do some background prep work. Keyboard shortcuts, which I mentioned. Handlers, again, that's for being able to manage multiple threads, basically manage work between your main UI thread and your background threads, which are doing data fetches or whatever they might be doing. Retrofit is a great library. I advise that if you're going to do networking. Room, I mentioned before, for data storage. If you want to research Kotlin, then you can go to that link there, and there's lots of tutorials to learn Kotlin. Also, if you're in Kotlin, there's coroutines and flows are available for other background research. But again, if you're just going to do a hackathon, you might want to stick to Java unless you got time to invest in learning Kotlin before the hackathon.
Great. Thank you, Chris.
Sure.
I'm going to take back this screen sharing. And so before we continue with our Q&A, if you guys want the resources or to go back onto the slides, we will be posting a PDF of our slide deck after this workshop. And then if you also want to look back on the recording, you can also do that as well, where we will post a link for that. Does anyone have any questions for Chris before we end this workshop? I'm guessing no.
Everyone's ready to build Android apps.
Exactly. You just gave them so much resources. So
Okay.
great. Well, thank you, Chris, for taking the time to present this workshop. And then to continue on with our hackathon preparation series, tomorrow we will actually be having a special event at 4 p.m. and we will be posting more about that on our Discord. And then for links to our socials, you can either scan the QR codes on the right-hand side, or I believe Patrick will be posting some links on the chat. And then also feel free to fill out our feedback form on how we can improve these workshops and anything about our hackathon. And from that, I hope you guys have a good rest of your week. Have a great rest of your Wednesday, and hope to see you guys soon.